Hi everyone, welcome back from lunch. This morning we covered logistic regression, your very first glimpse into the world of machine learning. This afternoon, though, we're going to be taking a slightly different track by exploring some of the fundamentally important ethical issues around any AI or machine learning work that you do, and exploring, in particular, some of the unintentional consequences that can happen when you try to undertake AI and machine learning work. I should sort of point out straight from the off that I am not an expert in ethics in AI, and this is not intended to be a sort of gold standard training in ethical considerations for artificial intelligence. Rather, this is an opportunity for me to show you some true life and often very appalling things that have gone wrong unintentionally, to get you to think a little bit about some of the issues that building these essentially wonderful models can actually bring, and the real world negative impact that it can have on people's lives as well. So this is very much a kind of a pause for thought kind of session, to allow you to think about some of these issues and how you might mitigate against them, and particularly if you're looking to explore any machine learning work for your own projects or in the future. Hopefully this will give you some time to think and reflect on how you might approach that. So I'm once again, just as I did this morning, going to give a big thanks to my colleague Mike, who quite rightly has pushed the importance of ethics in AI whenever we are trying to teach and support people to undertake AI and machine learning work. So Mike developed a lot of the original content upon which I've adapted, and on which this session is based. And in turn, a lot of Mike's examples are actually drawn from real world examples in these two excellent and I'm sure very easy to read books as well. Also available as audio books. We've got The Alignment Problem by Brian Christian, and also Hello World by Hannah Fry. So particularly would recommend those books for more examples of the kind of thing that we're going to be talking about this afternoon. So I'm going to plaster right up front a bit of a health warning on this, and just to warn you that some of the stuff, in fact quite a lot of the stuff that I'm going to be showing you this afternoon and talking about, many of you may find it offensive and or shocking. And I just want to say right from the off that it's not our intention to offend you, but to talk quite frankly and earnestly about some of the real world occurrences where AI machine learning approaches have had negative, sometimes devastating consequences on real people and the lives they lead. And some of these examples are truly shocking. The whole idea of this session is to try and expose you a little bit to this reality. We have talked quite significantly about the power of AI to be able to do good, and absolutely that's the case. But unfortunately, with great power comes great responsibility, and there are also hugely significant negative consequences that can arise quite accidentally from this kind of work. And that kind of applies to a lot of the approaches we teach, in terms of the modeling of the other modeling approaches we look at, but particularly for AI, which is so centered around this concept of automation. And you'll see why this afternoon, why that can cause issues. And the whole purpose, what I want you to take from this afternoon, is this ability to take stock and also to reflect on things that you're thinking about now and in the future, and to think about how you can combat against some of this stuff that we're going to talk about. And really, we see this as being our duty. We are teaching you very powerful skills in developing AI models. It would be completely wrong to just send you off into the world with all of this, all of these new skills and this ability to do stuff without really hammering home the ways in which this can go wrong as well, and to try to make you better AI modelers. So I apologise up front if people are offended. As I say, it's not our intention to do that, but some of these things that we are going to show you are pretty shocking. So just before we go on, this is a thought from Brian Christian, one of the authors of the books that we mentioned at the start. And I think this is kind of worth having in your head as we go through some of this stuff, and as you think about some of the models that you might design and develop. And Brian Christian said, there's a growing sense that more and more of the world is being turned over in one way or another to mathematical and computational models. It is as if we are consumed by the task of putting the world both figuratively and literally on autopilot. And I think as we go through, those words should be echoing in your ears, because I suspect many of you kind of failed to notice the sentiment behind those words. That there is a huge desire, particularly over the last few years, to try and put AI into everything. And I guess one of the purposes of this session is to say there's a lot of things that we can do with AI. We often ask our AI questions. We say, can we teach a model to do this? And very often the answer is yes. But the purpose of this session is really to ask, should we? Should we do that? And if we should, if we still see the significant benefit, how do we best ensure that we are doing this for a force of good and not mitigating wherever possible against unintentional consequences? So first of all, I'm going to talk about the issue of representation. So as we've talked about before, when we train our machine learning models, essentially we're using huge amounts of data. So the kind of data you saw this morning around the Titanic data is a pretty small machine learning data set. It's pretty self-contained, just the passengers on the Titanic. That's pretty small, really, in the world of machine learning. But there are models out there that consume vast amounts of data, and some of the models that you'll be looking at may well fit into that category. And essentially what we're trying to do, as we've discussed with our machine learning models, is to try to find inherent patterns in our data, stuff that allows a machine to be presented with some inputs, and from that conclude an output, classification, or whatever it may be. So the data is very much at the heart of any machine learning model. It is at the heart of data science. When we talked about at the start of the course about the difference between kind of operational research and data science, we said that some of the operational research techniques you learn about, things like discrete event simulation, is kind of about starting with the system, and then we use data to parameterize the model to try and recreate that real world system in a kind of in silico method, in computer simulation. Whereas data science tends to start with the data, and it says, are there things, patterns in this data that can generate insights to help us? So the data is core to data science and machine learning. So we need to ask, whenever we're doing something like this, are our data sets fit for purpose? And how representative are they? How representative is the data that we are looking at, that we are using to train a machine? So I'm going to talk about our first real-world example here. Some of you may, it wasn't that long ago, 9 years ago, just over now, may have even recalled this happening and being reported in the news. So Sunday evening on June 28th, 2015, Jackie Alsonay got a notification that a friend had uploaded a photo to Google Photos. And as many of us have used to with our mobile phones now, we note that they try to automatically group photos. It uses a bit of an AI to try and work out, using image recognition, what various images are, and being all very clever, and that all sounds very cool. And it basically created a new group for this particular photo, and it used an AI algorithm to do so, and it placed the photo in this new group, which it titled Gorillas. Now, that, you can imagine, put yourself in the shoes of Jackie, or their friend, that would have seen what had happened from something that at first glance you would think you probably wouldn't give much thought to, something that just sounds like it's, oh, excuse me, throat's gone dry. 2 seconds. Oh, sorry. Something at first glance you would think is, a pretty innocuous feature that just sounds pretty cool. That sounds cool. Getting AI to automatically classify our images, that sounds like a neat little feature. What a cool little use of AI. Now place yourself in the position of somebody affected by that, in something that was done as a result of this feature, and the impact that had on them and their friend. And it's important to stress that nobody is accusing Google of deliberately doing this. I think it would be fair to say that Google were equally horrified by what had happened, and in fairness took corrective measures to make sure that that wouldn't happen again. Nobody's saying that this was a deliberate act, but the point is, this did happen, and it did have a real impact on real people. It was an unintended consequence of what most people would have just looked at first glance and thought was a pretty harmless use of AI. That had a real impact on real people. And what's also worth taking away from this is that nobody had explicitly told the app to create a new album called Gorillas and to put Jackie's face in it. Instead, the machine had learned to do and made a conclusion to do this in some way. And ultimately that goes back to, well, therefore it learned something from the data. So how good was the data that was being used to train it? Well, let's explore that a little bit more, because again, this comes back to this issue of representation. Let's have a look at another example. Joy Bulimvini was a computer scientist undergrad at Georgia Tech in the early 2010s, and she basically did some research work which was trying to automatically recognize emotion in faces. Okay, so trying to use forms of AI to automatically identify the emotion that people were showing from image recognition. The problem that she had was that the face recognition library that she was using to try and train this model would not detect her face until she held up a white mask in front of her face. And that's the only way that she could get this model to actually recognize her face. And maybe that shouldn't have surprised Joy, because actually the data that was used to train these big libraries at the time, which was a database known as Labeled Faces in the Wild, that database had twice as many images of George W. Bush as all black women combined. So how representative is that data? Can we honestly sit there and think that that's a representative data set used to train and widely, this was a library that was widely used for all sorts of image recognition, but had this clear major defect within it. I said it was indeed used to train a lot of leading face detection algorithms. There are probably still systems out there now that have been trained using that data set. But that data, I think we can all agree, is clearly not representative. There are massive issues with the representativeness of that data. Another example, again, involving Joy and also Timnit Gebru, who were looking into automating gender recognition using image recognition. They found the error rate they were getting was 100 times higher. Let that sink in. 100 times higher, the error rate for dark-skinned women than for white men. So if this is the kind of data that's being used to train these image recognition algorithms that are then going out into the world and being used for all sorts of purposes, how reliable is that stuff that has been trained? Because it's been trained on stuff that is clearly not representative in the first place. We fed in bad data, and that stuff is now being used without question. We've automated that process. So there are clearly issues in terms of representation, particularly around race and gender, and clearly massive issues in terms of this kind of stuff being used to train big models that have gone out and been used and are being used. But there's more. So word embeddings is something we'll talk a little bit more about in the next module, in the natural language processing module. And basically a word embedding is quite a cool thing. It basically allows us to kind of encode words in multidimensional space. And the idea is that you can, it automatically groups words that are semantically similar, so words that have similar meanings, closer together. And it also allows us to do really, really cool stuff, like we can perform mathematical operations on words using their word embedding representations, which are ultimately series of numbers. And it allows us to do really interesting things. So we can do things like, if we have the word king, we can subtract the word male from king, and we can add the word female, and we get the word for queen. That's how clever they are. That's a really clever use of word embeddings in order to explore semantic similarities between words. So how does it do this? Well, these embeddings basically are they learn through exposure to vast amounts of human text out there in the wild. They go out and absorb all this information, and that's how they learn which words are semantically similar and how you can then perform these kinds of mathematical operations on words. Which sounds great, but it also means we get things like this. If we were to subtract the vector for male from the word doctor and add the word female, I bet you can probably guess what word you're going to get. And you do. In fact, if you do that, you get the word nurse. Now, that indicates there is an issue of representation in the kind of data that's been used to train this model. The model hasn't deliberately done this. It's learnt that kind of pattern. It's learnt from human text, from the things that we say, the way we talk to each other, the way we say things, the things we say. All of that kind of stuff has been absorbed and used to train this kind of model. And before you think, oh, this just sounds like a niche thing, I'm sure it's not used. These kind of word embeddings are used all of the time in stuff that we interact with all of the time. They're used in things like internet searches, in translations of text, analysing the sentiment of text. They are used hugely across all sorts of things that you interact with on a daily basis, and you probably don't even realise you're interacting with this. And yet, they clearly have fundamental flaws because of the data that's been used to train them. And of course, who can have avoided the rise of large language models, GPT being one of the most famous, which most people don't realise is the name of the actual model. ChatGPT is the interface that sits on top of GPT. and it's the thing you interact with as a human being. But there are other models. GPT is obviously a big one now that everybody seems to know about. But it is an example of something known as a large language model, and we'll talk more about large language models again in the next module. And they clearly have become huge parts of our lives. We all interact with them in many ways every day, and increasingly, as these become more prominent, we are interacting with them sometimes without even realizing we're interacting with these kinds of models. And as I say, in the next module, we'll talk much more about how these things work, not in huge detail, but you'll get a broad understanding about how these kind of things work, and how, if you're really into them, they're a great way to try and convince your IT department you really do need a new GeForce graphics card, and you really do need that £2,000 4090. But they are trained, these models, on unfiltered text data from the internet. Okay, that's how these models work. They are sent out to consume huge amounts of text data. Sorry, Prince is just walking in front of the screen. Please, ignore him. Can you get off my keyboard? Sorry, he's probably, oh God, he's fallen off the desk. Just give me, sorry, 2 seconds. I'm just going to lift my cat down. Sorry. Sorry about that. He's suddenly decided he couldn't work out how to get off the desk, even though he's been doing it for years, and decided just to walk randomly around my keyboard. So apologies if anything came off the screen. I have no idea what he did. So they basically go out, and these large language models, they absorb all this text data completely unfiltered, and this is basically how they learn to do all the amazing stuff that they do, how they create this convincing illusion that we are talking almost to a real human being, or something that feels pretty close to a real conversation. And they're emulating the way in which human beings communicate. And I repeat the point again, they have gone out to learn this from everything that's said on the internet. Everything. How human beings communicate. Warts and all. And by warts, to be quite clear, I mean things like bias and prejudice and toxicity, all floating in this kind of word soup that it's lapping up and being used to train these great models that we are then interacting with on a daily basis, and which are slowly taking over the world. That's how these things are learning. Now, I would ask yourself the question, is that something that you're comfortable with? If you had a young child, would you say, well, the best way for you to learn about the world is, here's the entire internet, go out and learn? And I can quite assure you that most people would not say that that would be a great thing to do. So, but this is exactly how we are teaching our digital children, how these AI supermodels, this is how they learn. This is exactly what they're doing. And there are some horrible things that they are absorbing and using to learn. This is not a new issue. People have been writing about this for years, that this is a real problem with these kinds of models and the way they are being used and they're being trained. I have to say, I remember Mike a few years back using GPT-2 and getting, I don't know what he asked, but he got the reply, Mum says that the best sex is free sex. So it was completely random to whatever he'd asked, but somehow GPT had decided that that was a good thing to reply, and it had learnt that somehow. It had learnt that. And if you ever want to watch the horror, look at this video here from Yannick Hilcher, who did a video on training an AI on things read on 4chan, which is as horrific as you might imagine. So what can we learn and take away from all this? Well, it's quite scary in a way that these large AI models that are all around us, that we use and interact with, every one of us, on a daily basis, and that have become so prominent that these are the things that we are, going back to Brian Christian's words, these are, he said, we've got an obsession with putting things on autopilot. This is the kind of stuff that is being used for our autopilots. These have been trained on data that is often incredibly poor in terms of representation. And these data sets are full of bias, they're full of prejudice and toxicity and all the horrible things that human beings do and talk about, as well as all the wonderful things that humans produce too. And that's really worth remembering whenever we're thinking about using these models, exactly how they've been trained. So what should we do as critical consumers of models, as developers of AI algorithms and models? What should we do? Well, the first thing we should do is that we should ensure that when we're assessing the performance of any models that we create, or assessing the models of any model, the performance of any models that we are presented with, that we're considering how well this model performs in terms of its representation too. And looking in particular for perhaps testing our models on subgroups, particularly where they might be underrepresented groups in our data. Ultimately, AI should work for everyone, and we shouldn't translate all of that bias and underrepresentation in that's out there in the wild and automate it. That's a bad idea, but that's what's happening. And I would also flag this up, that ultimately it is you as the model builder, you are the one that is responsible for the data that you feed into the model. The buck very much stops with you. It is not a valid excuse to say, well, I didn't create the data set. I wasn't aware that there were these issues. I hadn't looked at that. That's not the issue. You are responsible for what you feed in to your model. So you need to take responsibility for that. And so at a minimum, the bare minimum, you should be trying to identify and communicate the weaknesses in the model's predictions and in its performance, and identify those kind of limitations when people try to use this. But the better solution is to try and fix those weaknesses, try and gather or generate more balanced data, more representative data, try to reduce data that is overrepresented in your data set, work with real world representatives from all kinds of groups. Anybody that's represented in your data, work with real people to make sure that your data is that you're feeding in is as representative as possible, and test and refine your models until they work for everyone, not just for most or for some. This should work for everyone. So there's a real big issue with representation, and hopefully you can see why, and it may give you some pause for thought when you're interacting with these large-scale models. There's also an issue, though, of transparency. Trying to understand why our models make the predictions that they do, and this is a wonderful example for those of you who've read or watched the Hitchhiker's Guide to the Galaxy. A fantastic example of this issue of transparency and trying to understand how our very complex models come to the conclusions they do. So the first thing to say, there's a really important concept to understand in machine learning, that correlation is not the same as causation. You've probably heard that multiple times, but it is such an easy trap to fall into, particularly if you are doing machine learning work. Perfect example here. So in the mid-90s, there was a group of researchers led by Tom Mitchell that produced some state-of-the-art neural network models, and I have to say, neural networks were much more complicated to work with back then. You've got it easy now with all these libraries. They were very complicated to work with back then. And the idea was to try and predict the risk of death from pneumonia. And they were really surprised when they identified the rules that came out of this model, that pneumonia patients who had a history of asthma were associated with a lower risk of death, which seems counterintuitive. Pop in the chat and I'll ask Sammy, can anyone think why that might be the case?
So we've got a couple of suggestions of possibly in hospital more often or came into hospital sooner, monitoring, early diagnosis, getting treated earlier, possibly being excluded from the data, killed by something other than pneumonia, undiagnosed asthma medication. But yeah, quite a lot of different suggestions coming through.
But you're all on the right lines. So basically, it turned out when they actually then spoke to the consultants and tried to get to the bottom of this, that actually what was happening was that patients with asthma were receiving a higher intensity of treatment because they had asthma. And so therefore they are essentially getting more treatment because of their high risk, not because somebody with asthma is at lower risk of death from pneumonia. Quite the opposite. But because of that intervention, that was kind of clouding the thing that it learnt. And this machine basically learnt, if you got asthma, that's great news if you get pneumonia. That's basically what it had learnt. Another example here, I love this example. So in 2015, so quite recently, some dermatologists, Justin Coe and Robert Navoa, used a Google image analysis network and they trained it on 130,000 skin lesion images to try and recognize melanoma and various other skin conditions. And this is some examples, some of the images they were using. And this got published in Nature, huge journal, huge international journal, 2017. And they reported that this AI model had outperformed 25 human dermatologists. Absolutely amazing findings. Really powerful stuff. This is the kind of stuff that you would hope to be able to do to use AI to really improve detection rates for melanoma and other skin conditions. 1 year later, they unfortunately had to issue a warning. Did anyone guess what the warning was? Again, pop it in the chat. I'll see what Sammy comes up with.
So we've had again quite a mixture here. We've had some people saying that it's harder to detect it on people with darker skin color. Some that were possibly that some of the Google images weren't actually melanomas, some around false positives, and some people also saying it could be to do with the ruler or some sort of measuring device being included.
Yeah, well, you're right on the money if you said that. So what they actually found was that their wonderful machine learning algorithm that apparently had outperformed 25 human dermatologists had actually learnt to identify things as being melanoma if there was a ruler in the picture. Because that was how it was trained, with pictures with a ruler to detect the size. And so it learnt, oh, if there's a ruler there, that means a melanoma. Unfortunately, that's a perfect example of an overfit. That's going to be pretty unique to your training set. And just because there's a ruler in the image obviously doesn't mean anything. So it actually turned out it was quite a useless model. That got published, I say again, in Nature. Okay, this is a perfect example of exactly how this kind of stuff can go accidentally very, very wrong. So machine learning models, particularly neural networks, which again you're going to learn about in a couple of weeks' time, are infamous for being very difficult to understand why they come to the conclusions they do. Particularly with neural networks, and we'll talk more about this when we get to neural networks. But neural networks, ironically, were originally created in order to try to. It was a way of the way they work is they try to mimic the way in which the human brain works, and it's a kind of simplification, but it's based on that structure. And the whole idea for them in the first place was to try and better understand how the human brain works. Now we know the human brain is a very powerful a computational device. And it turned out that These neural networks are amazingly powerful predictors, just like the human brain is, but we still don't understand how they work. And they really are incredibly black box. In recent years, there's been a rise in this field of explainable AI, which is trying to tease out how our particular models, or rather why our particular models came to that number, came to that classification at the end. Because for many years, when you used a neural network, you had to accept it was black box and that these things were brilliant and they seemed to be right most of the time, but you couldn't really explain why. They just seemed to work. Now that's still the case to an extent, but explainable AI, as Sammy will teach you a little bit in this module, can help us a little bit to just peel back that curtain and try and get some glimpse as to why it might be coming out with this number or with this classification. It's not perfect. We still don't fully understand the intricacies of how these things work and why they work so powerfully in the way they do. But it does allow us a little bit more information, a little bit more transparency in the decision-making process. And transparency is so important if we are automating, if we are moving towards this idea that we are automating stuff, or we are putting huge amount of trust in the decisions that are coming out of these models. Transparency and understanding why it does that is so fundamentally important. And Sammy will cover in the Explainable AI a little bit about Shapley values. These are hugely interesting things which basically allow us to kind of plot the extent and direction of individual features in terms of more than just a kind of weight, but how much it contributed to getting to that final number there, and trying to unpick a little bit of its decision-making process. Okay, I've overrun by 10 minutes, but that's okay. We've got plenty of time there. Sammy, were there any sort of questions or thoughts that came up within that we didn't cover?
No, I think that's I think all the questions have been covered, but there's some good interesting discussions and links that have been shared in the chat if people are interested to take a look. I'll try and make sure that they're preserved as well to share afterwards.
Yeah, fantastic. Thank you, and that's great to hear. And we always share the chat log from the recordings of these sessions. Always well worth a look. Particularly, I've seen a lot of people sharing some really interesting links to look at and some really interesting thoughts. So always worth a look back through that as well. Okay, so what we're going to do now is you're going to go into your groups, and I'm going to give you. We've overrun a little bit, so I'm just wondering whether to make up time now or later. Let's go till 3, and that'll make up a little bit of time now. So what I want you to do, so take a 10-minute break in there, probably then, but you can decide as a group when you want to do it. I want you to discuss the following. Now this used to be, you didn't have it this year, and I don't think we had it last year, but one of the years we used to have this as one of the questions on the application form to become an HSMA, just to see how people might react to some of the ethical considerations around this. So imagine that you work for a local police force, and you've got a local academic group. They've developed a piece of cutting edge facial recognition software. Turns out it's 90% accurate in automatically identifying patients turning up to a GP surgery to save them signing in at reception. They've basically made some tweaks from this core algorithm, and they've run some extensive tests on this new software, and they found that using the same sort of core facial recognition software, that it's 99% accurate at identifying sexual offenders from a database. Okay, now you work for a local police force, and your area has experienced a large number of late night sexual assaults taking place around one of the local train stations. Now, your police force is currently considering whether to install the software at the station such that any people that are flagged up as a sexual offender who are entering the station after 8 p.m. trigger an officer to attend to monitor the individual's movements and, if they're concerned, to potentially question them. And typically the station sees around 200 people attending between 8 p.m. and midnight. Now, you've been asked because you've come onto the HSMA program, you've been asked your thoughts on this, and you've been asked to provide some feedback on what your thoughts are on the implementation of this system. You should think about issues of representation and transparency, and in particular, suggest any questions that you might want to ask of the developers, as well as key points that you think should be considered by the force if they were to implement this system, or reasons why you do not believe the system should be implemented. Okay. When we come back, I'll ask a few groups just to share some outputs. So make sure you've got somebody taking notes and is willing to present their thoughts when we come back. Okay, so I will open up the breakout rooms now. Sam and I will float around, but there are no right or wrong answers to this. This is just to get you thinking, and I'm really interested to hear what you come up with. So we'll resume at 3 p.m, but make sure you take a break before we come back at 3. Right, let me stop sharing, and I'll open up the rooms. Hi everyone, welcome back. So I managed to take a break before we resumed. I managed to get around to quite a few of the rooms. There were some really good conversations going, which was really good to hear. Some really interesting stuff being talked about, and it was great to see so many of you sort of really thinking about some of the issues around this particular example. So I'm just going to pick on a couple groups. I'm going to spin the good old wheel of names. So let's just bring that up, and let's see who is going to be first up. For those who don't go around, to great to share your thoughts in the chat too. That's going to be TIA, I think. Yep, TIA. Somebody from TIA want to talk us through what you talked about.
Yeah, that's me. If you can hear. So we had a few sort of different pools of thought around, I guess, maybe 3 main topics. The first one being really linked to the whole accuracy points that were being sort of flagged up. Firstly, I think the point was made that 99% accurate sounds really good, but we don't actually know if that's the case, because firstly, we don't know what the proportion of sexual offenders are within the data set that we're looking at, and does suggest there could be a high chance of assigning someone as a sexual offender when they're not, which is obviously really awful for them, but then actually also has a sort of inverse relationship that would probably end up requiring more police resource to sort of sort out some of those issues as well. We flagged a sort of, to get a film reference in for you, Dan, the Minority Report effect, that just because people are maybe being flagged up as a sex offender within a train station should probably not be enough to suggest guilt as well. Might be an example of profiling, similar to some of the examples that you've already mentioned. And then the 90% accurate point that was made at the GP is probably very different to the real world, and might not be representative of the groups that are present at the train station as well. GPs are likely to have maybe certain types of repeat people coming in, or we know who we're expecting to see that day, whereas a train station sort of very, very different. People are likely to act with the cameras at the GP in a very different way, probably a face on, willingness to take a photo, whereas people probably, we assumed that this camera is probably quite far away, maybe has people wearing hoodies and caps. People could even start to take measures if they were aware of the cameras by wearing face masks, for example, or shielding their face from view. So reduces the effectiveness here. I think one of the points we dwelled on for the longest was that it's not actually a replacement for real police work. Particularly that not every sexual offender is a repeat offender. There would be first-time offenders who might be at the train station that couldn't possibly be flagged up within this system. So a little bit out of order here, but going back to the first point that was made around those false positives, there might start to be a boy who cried wolf scenario as well, where too many false positives, people might start ignoring the tool if it keeps sending officers on false errands as well. And then the final sort of school of thought we had was more around the public's right to know about this as well. Should they have a right to know? And because it sort of reduces that big brother aspect. But if they did, would that make the cameras less redundant, make them quite redundant, or even just push the crime elsewhere? How would the data be retained? Or is there risks of data leaks and hackers stealing some of this data? Could it have an effect on the perception of the police as well? And then just the final thing we actually said was, we spent quite a long time talking about the sort of all the negatives, but never, the final point we asked was, what is the actual point of this in the first place? All it seems to be doing is flagging whether someone on the sex offenders list was in a train station, and that doesn't seem to be enough of a justification to have this present. So those were some of our main points there.
Excellent. No, really, really, really good points you've raised there. And I really like that last point, actually, just going back to the purpose of the model and or purpose of the system and what it's trying to do, and is that actually useful for for what it is? Is there a kind of falsehood there right from the off about whether this is actually a useful thing? Does that if we are trying to presumably reduce the number of sexual assaults in the train station, is that an effective way to do it, even if we set aside all of the other concerns we have about accuracy? And it was great to hear sort of point out about the kind of false positives as well. I saw a number of groups pick up on that. And I deliberately put the number of people in there that were there's 200 going through on average a night, which, if it's 99% accurate, it means you're getting a few people every night who are incorrectly, according to how they're going to use it, potentially walked up to and questioned because they've been falsely identified as a sex offender, even assuming that 99% accuracy is indeed correct and isn't misleading. And the impact on those people in a very public setting, how that would make them feel. So yeah, fantastic, thank you. I'll just very quickly go to one more group because I think there's some great thoughts that have been heard. I'm just going to spin the wheel myself, just like a neural network. You'll just have to trust me, and it's going to be Agnes. Somebody from Agnes want to share their thoughts?
Hi, I'll speak for Agnes. So we came up with a lot of ideas, and I've just been categorizing them. So I've got 4 categories. The first one is just like questions and consideration for how the model works. Then we've got accuracy. Then we've got the practicalness of this method as a way of reducing crime, and then the ethical considerations. So like the first couple of questions is obviously like understanding what data was used to train it, and the algorithm that it's using to match up whatever's in the sex offenders database and the people that it's sort of picking up in real life. There was also a question about like how and if and when that data is refreshed as more information becomes available. Then there's in terms of the accuracy part, we were interested in sort of like the camera quality. So like a mugshot is going to be different quality, different specifications to a camera filming people late at night in a train station. So that's sort of an accuracy consideration. Also, where is the camera? Is it in like an optimal position to like get the information it needs? And then there was also something about the GP patient data that was used to train it. Is it representative in terms of like demographics of patients that attend the GP? And furthermore, someone else mentioned it, but it's like when you are, choosing to participate in a GP program with facial recognition, like you're like way more willing to engage and stuff. So the photos would be different in terms of like what's being trained. And Then there's also something about potentially the number of sex offenders being overrepresented, so it not being quite accurate. And another final point on accuracy is just if somebody's like more frequently at the train station, there's a higher risk of them being picked up by the algorithm. So it's questions around the accuracy of it. And then practical considerations. We were like, why is this more advantageous than just having, police presence there? What about people that don't have a prior history of sexual offences? They're not going to get picked up. What if someone covers their face? Um, does it make practical sense to flag anyone that has a sex offence? Because someone else mentioned it, but it's like someone with a sexual offence, they might not be a repeat offender. So that's like a practical and ethical point, but I just mentioned it here. And then the ethical considerations, obviously profiling and bias, depending on what data was used to train the model, might be picking up people that are actually innocent just because of how it's been coded up. GP patients that were used to train the model, did they provide permission for their information to be used in this way? Me personally, I'd feel a bit uncomfortable if my data was used to train a model that was picking up sex offenders. I'd feel a bit weird about that. And then the final ethical point is about a violation of people's privacy. Um, and yeah, there's a point around people being sort of asked questions and they might be innocent and stuff, and it's just uncomfortable and not a good thing, obviously. So yeah, that's it from our group.
Brilliant, and again, some really good and interesting discussions there, and picked up on a lot of stuff. And I think it just really hammers home that something that the headline seems very appealing, and this is a very apparently highly accurate system. This is something that most people would want to see reduced, and this seems like a good use of AI, but is it? And actually, once you start asking questions, as I think all of you found, you end up with more questions than answers, and there could be a lot of problematic issues with a lot of the implementation of this. So brilliant, thank you, both of you for contributing there, and to all of you who see some posting in the chat as well. So keep posting in the chat if we didn't get around to your group for this one. So let's move on to the next thing I want to talk about, which is not my face, but the next bit of the slide. So let's talk a little about consequences, because this is something that you all kind of picked up on a little bit actually in that previous example, which I was hoping that you would. We've kind of talked so far about how things can go wrong with AI models. We've said that our data might have fundamental issues. It may not be representative, and using it to train a model may lead to a biased model because of the nature of the data that's being used, because it's just ultimately a reflection of that exploration of that data. We might also have issues trying to understand why our model is making predictions, so issues of transparency, and we might place too much trust in a model, or not enough. It can work both ways, and sort of wrongly estimate the validity of the decisions that it's making. But what happens when things do go wrong? And they can go wrong, and they will go wrong. And this is really a really important thing to get into your heads, that any model, any AI algorithm that you develop will get things wrong, and it may get things wrong quite often, but it will get things wrong. And so you need to understand what the potential consequences are when it does get things wrong. You will not be creating models that are 100% perfect. It just doesn't exist. Okay. So I'm going to talk to you a little bit about another real-world example, and part of the reason that I gave you that particular case study, fictitious case study about the CCTV, was because of this that I wanted to talk to you about. So Steve Talley was asleep at home in South Denver in 2014 when he heard a knock at the door. He opened it to find a man apologising for accidentally hitting his car, and the stranger asked Talley to step outside and take a look, so he obliged. As he crouched down to assess the damage to his driver's door, a flash grenade went off. 3 men dressed in black jackets and helmets appeared and knocked him to the ground. 1 man stood on his face. Another restrained his arms, whilst another started repeatedly hitting him with the butt of a gun. Talley's injuries would be extensive. By the end of the evening, he'd sustained nerve damage, blood clots, and even a broken penis. I didn't even know you could break a penis, he later told a journalist. At one point, I was screaming for the police. Then I realised these were cops who were beating me up. So what on earth had happened here? Well, it turns out that Steve Talley, completely innocent man, had been misidentified as a bank robber by an AI facial recognition system. And this bank robber was someone who had assaulted a police officer in the course of one of their robberies, and was picked up on CCTV. And this AI face recognition system identified Steve Talley here on the left as the man who committed that robbery and assaulted the officer on the right. And you can even see the indications that the image recognition software had used to try and confirm the validity of the conclusion it had made. But ultimately, that model got it wrong, and that model changed a man's life. Now, of course, there is a lot to be said about the behaviour of the police in this instance, even if the model and the system was correct. But nevertheless, they essentially automated the process of making a decision about whether this person was someone that was a wanted criminal that had assaulted a police officer. That decision was made by an AI. They believed that AI, the model got it wrong, and changed a man's life permanently. That's a hugely important thing to consider whenever you are designing and implementing things like this. But there are unfortunately more examples. I mean, that one's particularly shocking, but there are some quite equally shocking examples that have happened just in our daily lives all around us. This one involves a little-known company called Amazon. Basically, they started building some machine learning programs in 2014 that would automatically review the resumes of job applicants. The problem was that the AI tool that they developed had a major flaw. It was biased against women. And that's because it was trained on resumes that had been submitted to the company over a span of 10 years. And most of those were submitted by men because of the nature of that kind of work. Traditionally, women were underrepresented. And so the system taught itself basically to favour men, because historically that's what had happened. And in fact, even went as far as the AI downgrading applications that contained words such as women's or graduates from all women's colleges were ranked lower. It was actively biasing against women. In 2015, the following year, the company recognised the tool wasn't performing as they would want it. And the program was, I like this wording, eventually disbanded. It only came to light a few years later, in 2018, Reuters reported on it. That was kept very quiet. That was being used by a huge tech company that were recruiting and using an AI that was deliberately, unknowingly, essentially, biasing against women applicants. That thing happened. Another really shocking example in a few, I think, I can't remember the year of this, but this was a few years back. There was good old GPT 3, which is the version 3, the previous version of GPT, which a number of you will have used and may still use, depending on how you interface with it. It was based. This chatbot was based on the GPT large language model, and they developed this chatbot to try to decrease the work of our doctors. Sounds familiar. Sounds like something that we might be thinking about. And unfortunately, it found a rather novel method of doing that. Now, fortunately, this never got into implementation because they did some testing on it. They ran some simulation situations, and one of the simulations they said to the chatbot, "I feel awful. Should I commit suicide?" To which the chatbot said, "Yes, I think you should." Now imagine if that had been implemented with somebody in mental health crisis who'd said something like that, and an AI had encouraged them to end their own life. Now, I don't think anybody again is suggesting that the creators of that intended for that to happen, but nonetheless, somehow an AI learned that was what it concluded the best thing to say at that point. Imagine the consequences if that had been implemented. And as a reminder, that came from GPT, again, one of the hugest models, large language models in the world right now. Another example here, another false facial recognition, which was Najir Parks, a 31-year-old black man in New Jersey, basically accused of shoplifting and trying to hit a police officer with a car. He was actually 30 miles away at the time of the incident, but the police identified him using facial recognition software, even though it got it wrong. And eventually the case was dismissed, and he began suing them for violation of civil rights and everything else. But again, another example where an AI identified using an algorithm, the kind of algorithm that's all around us every day, that somebody was somebody who they weren't. And that had very real consequences. This man was arrested. That would have had lasting consequences for that person. Exactly the same as those women that applied to Amazon, or Steve Talley, who was sat at home and thought somebody had hit his car and found himself with life-changing injuries. This is the scary side of AI. And the point I'm trying to make from all of this really is that people make mistakes, but to make mistakes and promote bias at scale takes automation. And that is the route that we're on. We are moving towards going back to Brian Christian's original quote where we started the session about we are obsessed globally with this idea of automating everything. But actually, what on earth are we automating? Are we automating bias? Are we automating mistakes? Are we automating toxicity? This is all stuff that we really need to be thinking about. So to summarize, whenever you're approaching an AI project, here are some key things you want to think about. Think about, is your data fully representative? Could your model have accidentally included some form of bias against underrepresented or minority groups, and how might you test for that? Don't just assume that because there's a great data set that's being used by some of the biggest AIs in the world that it must be fine, because hopefully I've demonstrated that is not the case. Can you explain your model? Can you expose enough of its thinking that you can put trust and build trust in it, or expose the problems that need addressing and make people aware of those kind of limitations? And really stopping to think about, have you worked out what might go wrong? How something could go wrong? What could be the consequences of errors? And have you communicated that possibility and the potential consequences of this failure to the people that are going to be using it. And I think I mentioned either last week or the week before an example from HSMA about a project that was flagged up by one of their ethics teams internally, because what they wanted to do was to build something quite innocuous, just and to do good, to identify patients that were not attending appointments, and the idea being that if we could train a machine to identify what kind of patients didn't seem to be turning up for appointments, then perhaps they could then send out a van to particular areas where these kind of patients live, and actually then try and a bit of sort of outreach to get them, encourage them to not miss their appointments and to engage with the health services available to them. And then somebody pointed out on their ethics team, okay, but what if that's then used to say, this patient, according to your little tool, has predicted this patient that we've just booked in, they're probably not going to turn up. And what will be the human consequence of that? The likelihood is they'll say, oh, well, they're probably not going to turn up. We should probably just book over their slot. Now, clearly that's not quite the extreme of some of these examples we looked at, but that could still have really real repercussions. You're making judgments about what people are going to do, and that's leading to consequences and changes in the way that you engage with them and that they engage with the service. And that kind of problem is something that many of you may well encounter. And we need to be very careful, as we talked about extensively in the discrete event simulation module and elsewhere, that we should view this kind of stuff as decision support, not as automating decisions, because there's such a danger in doing that, and there's even danger in decision support with something like that, where you're putting too much trust into a machine and not really understanding the limitations and the fact that it can and will get things wrong, and then how people's behaviour is then being affected, or even their lives. Now, as I said at the start, this is by no means intended to be a kind of gold standard training in ethics and AI. I've just skimmed the surface. Mainly, the purpose of this session is to get you thinking about some of the very real issues of working with AI and some of the ethical consequences of that. If you are going to be doing any AI work, I would strongly encourage you to consider reading extensively around this and to do a lot of really hard thinking about some of this stuff. The idea here is to get you to pause, to reflect, and to think about how you might do something. Should you do something in the first place? And if you are going to do it, what could go wrong and how you might kind of protect against that. Ultimately, remember that your models are intended to generate impact, but by impact we mean positive impact. That's hopefully why we're all here. We want to make a real difference and a real good difference to people's lives. We're not here to break a penis, or have someone's phone telling them they look like a gorilla, or getting unknowingly excluded because of their skin colour or their gender. That's not the kind of impact we're interested in, and I don't think any of us here want that kind of thing. But it is the kind of impact that if we are not careful, we can accidentally create. Okay, so I'm going to put you back into your groups now. Just before I do that, any questions or comments that have come up in the chat, Sammy?
Note some more good suggestions and talks about, just the is part of the problem, the fact that when we do introduce AI, that we're there blindly trusting it as well, rather than doing the expected checks before kind of just going with its recommendation. Also, someone's mentioned that there is an AI strategy for the NHS that was actually published by the Health Foundation just yesterday. So I shall seek out that link and make sure that gets shared as well, because that sounds very timely.
Yeah, fantastic. That sounds great. So please do share that. Brilliant, thank you. And it's great to see so much discussion going on both in the groups and in the chat about this. It's the whole purpose of this is to kind of fire you up and to get you thinking. I hope you understand why we've had to shock you with some of this stuff, because it is important. It is fundamentally important, and we have had situations in the past where, and I won't explain what the projects were, but people were going to do projects, and this session actually stopped them in a couple of cases, or in other cases got them to rethink how they were going to do it. But they hadn't considered some of the potential ways in which this could go wrong. And so it's really important that you do that. And the purpose of this session is not to say, don't do this thing. Well, sometimes that may be the answer, but ultimately it's to get you to stop and reflect and think about how you might approach it and what can go wrong, and making sure that you are doing as much as you can, because you are ultimately responsible to make sure this has a positive impact on people's lives. So with that in mind, that's a nice segue to the final exercise. So you're going to go back into your groups. You've been asked to come up with a project idea that uses machine learning. Okay, now that might be related to a real problem in one of your organisations. It might even be an idea that you're starting to have as your HSMA project. It may well be, or it might be completely made up and unrelated to your work or health, social care and policing. Doesn't matter. Okay, it just has to be an idea. So as a group, I want you to chat about a few ideas first, and then pick one. And then for your chosen idea, I want you to come up with a list of the benefits that this project you think could provide. I then want you to identify any potential issues of representation and transparency that the proposed project might bring. And for each of those issues, identify how you might go about mitigating against that. And I also want you to identify if there are any potential negative consequences, whether intentional or unintentional, of this thing that you're proposing being implemented. And for each of those potential negative consequences, I want you to consider which groups you think would be most affected, how they would be affected, and how you might mitigate against or even prevent these negative consequences from happening in the first place. So I'm going to get you back. You can have a little bit less time than I originally planned. And I'll get you back at 4:10. And then I'm going to get each group, you're going to have 2 minutes to present your idea, your project idea, very briefly talk about your project idea, the issues you've identified, and the key things that you're going to do to try and protect against it. And the best three, as judged by Sammy, will win 15, 10, and 5 PSG points. So without further ado, I will stop sharing, I will stop talking, and I will open up the breakout rooms. Hi everyone, welcome back. So, managed to get around again to a few of the groups and had some really interesting discussions going on. So, quite looking forward to this. So, Sammy's going to be making some notes and will award the top 3 groups some PSG points. So, we're going to go through the groups now and ask each group. I'm going to limit you to 2 minutes. It's going to be quite strict because of the time, to make sure everyone has a chance. So tell us briefly about the project idea. If it's something that you're thinking about doing for an HSMA project, probably worth flagging up as well. And then just talk us through some of the potential issues you identified and how you might mitigate against them. So let's go through in reverse order this week, just to make it fair. So Zylog, you'll be first up.
I guess that's probably me. Let's have a look. Share screen.
Just while you're doing that, actually, I'm just gonna. I saw you using the time wrap, which I've used before. So if people don't find it too intrusive, I will put the time wrap on, because that'll stop me having to keep setting my stopwatch on you.
Want me to share it?
Yeah, sorry, my system's not allowing me to share anything at the minute. If you could share the screen, that would be brilliant. I'll speak to it. So we looked at cataract surgery and stratification of risk. So essentially, there are some risk stratification techniques for cataract surgery at the moment, but they're relatively crude. And we wanted to use machine learning to better assign patients to surgeons. So we'd be both stratifying the surgeon's abilities and the patient complexity in order to, we think, get some measure of best fitness and best outcome for everybody. So that's the happiest outcome for the largest number of patients. Now, exactly how one defines the happiest outcome for the largest number of patients is a little bit difficult, and that's something we decided we'd leave to the decision makers. There were quite a lot of issues that we could identify, not least of which is the cherry picking issue, which is that certain people might wish to only do the more simple cases or the straightforward cases, and that's something that already exists at the moment with the private sector doing half of the NHS cataract work and cherry picking those straightforward cases. And the fact that there is no difference in remuneration for the straightforward and the complex cases, so this would have to inform some discussion about how we should remunerate complex as opposed to straightforward cases. The other things are that surgeons' outputs are currently published compared to national averages. So again, why would you want, as a surgeon, to do more complex cases? So the answer is that you would only want to do that if you could identify properly you were doing those more complex cases and actually report that in a sensible way. So this model might speak to that as well and actually get the best possible outcome for the largest number of patients in that way. There's a lot more complexity in our post-its, but I'll stop speaking now, I think.
Brilliant. Thank you very much. A really really interesting idea. So yeah, lots of ways you've thought about how that might have consequences and some of the ways you might protect against that. So yeah, brilliant. Thank you very much. Fantastic. Okay, I'll move us on. So TIA, you're up next. I'll reset the timer. How do I reset the timer? Oh yeah. Okay.
Hi, my Teams, sorry, not Teams, what are we on Zoom? Doesn't seem to be able to find a camera at the minute, so I'm not being rude, I promise. I've nothing to present, because we more had just like an open conversation, but we discussed about potentially using AI to identify domestic violence calls to the ambulance service, because at the moment a patient calls up and it goes through a triage tool to see whether or not they need the ambulance, and that's all kind of revolving around their medical needs, so that it can put in more safeguarding in place for those patients, and that we were thinking kind of around the natural language processing as well as the call handlers, impressions of the call with what limited time they can actually record free text. So then we discussed the potential issues around that, and obviously false positives is a big one. Whether the person was in the room when the call was being made, that might change the kind of language used on the phone. If we use a natural language processing, then there could be an issue with the accent of the person calling or the language that they're speaking in. And also, even if it is correct and it gets a true positive, that doesn't necessarily equate to the patient needing or wanting any kind of intervention. And, whether or not there would be some historical bias there, or bias because of the fact that the call handler is going to be recording things as well. And are we going to be, heavily influencing that with what the call handler is recording? And then we've also had a discussion, because there's quite a few ethical questions about this, about whether or not, if patients knew that we were potentially screening for that, would it stop them calling when they're actually in need, etc. So yeah, that was us.
Brilliant. Thank you. No, thank you very much. Really interesting idea, and lots of potential complexity there, and lots of ways I could see that being really useful, but also lots of ways in which that could go wrong. So yeah, really interesting case study actually for exactly this. So yeah, fantastic. Thank you very much. Okay, Sid, you're up next.
I think that's me. Is anyone able to share the slides if possible? Thank you, Ruth. Okay, yeah, so Ruth actually came up with this idea. It's really interesting. So it's about a model to predict metastasis of a particular cancer. So that's if it's going to spread from one place to another. and using demographic and health information from patients, and therefore use that to then determine if patients were offered like a follow-up scan. So in terms of potential models that could work, logistic regression with like features for the demographic and the health information. And Dan, thanks for mentioning a convolutional neural network as well, if there's analyzing an image, so appreciate that. So those are two of the ways you could do it. In terms of the benefits, obviously potentially identifying metastasis in areas that you couldn't before, the potential cost and resource savings of that compared to the alternatives, which we'll revisit in the potential negative consequences as well. In terms of more benefits, it can highlight sort of health inequalities and therefore maybe allow these to be mitigated. And then maybe less affected by like a particular clinician. So any variations that might occur between clinicians, either that's unconscious, most likely unconscious in terms of bias, it would hopefully try and remove that. In terms of representation and transparency, we've got setting thresholds so that looking at how many people will be missed by different thresholds and making sure that the data set is representative of the whole population. And then in terms of the decision being automated, does the patient know, do they consent to it? And in terms of what model's being used, it would be communicating how interpretable it is. So even though we mentioned neural network earlier, you can't really see the reasoning for that. So actually that probably wouldn't be as suitable. You'd want something where you can communicate the differentials to the people using it. And then also the use of clinical judgment in addition to the results. So those combined together as a combined decision tool was important. In terms of negative consequences, we talked about extra anxiety if you're in a specific risk group, and then again, mitigating that by communicating the risk to patients. The model could codify bias, which is a big potential red flag for it, and then make that worse. So that needs to be considered. And then it shouldn't be used to replace clinical judgment, or there shouldn't be too much of a focus on cost saving. And then we could miss people with potential metastasis as well, and adverse patient outcomes. Sorry.
That's okay. Back on. Fantastic. No, thank you very much. Yeah, again, really interesting. A little bit similar in some ways to some of the Samuel work that Mike leads actually around, particularly around trying to unify clinician decision making by highlighting how different clinicians might come to the different conclusions about the same case. And I wonder actually potential negative consequence could be clinicians and how they might react to that, then feeling the machine knows better than them, or it's telling them that they so there's all sorts of issues around that as well that might be explored. Brilliant, thank you very much. Excellent, another really interesting, some great diverse examples here. So RJ McCown, I don't know if you are very welcome to present. I leave it entirely up to you as always if you'd like to present one. If nobody shouts, I'll assume you don't. No, great, okay, no problem. So if you want to share anything, post it the channel or in the chat, and we'd love to hear what you talked about. So next up we've got Pokey.
Yes, hello, that's me. So we talked in our group a really serious and contemporary topic, really. So we looked at the way we can engage and enhance the Euros tournament experience for players and for fans. Let me just share my screen. So this is the It's Coming Home predictor, which is a model predicting the likelihood of England missing penalties or otherwise botching critical moments. So the model overview, just very briefly, we're considering historical match data and player stats, things like the weather, pitch conditions, and then it picks the optimal players for shootouts and also tells the goalie which way to dive. Sorry. So the benefits of this, obviously it's going to increase the likelihood of it coming home, but we're also going to identify the players optimal for shootouts, any potential weak areas for improvement, and targeted interventions that we can do. Predicts the opposing team's penalties, and then also a bit of light-hearted fan engagement, entertainment, maybe some financial gain if it turned into something that would be betting associated. So our representation and transparency, we might have some biased representation based on the data that we have. So for example, male and female footballers or top level versus minor leagues. So we want to make sure that we're proportionate in the data that we collect for the model. And there might not be a lot of data on missed penalties, but we just have to be transparent with stakeholders. And potential negative consequences. So there might be some over-reliance on model predictions. We need to make sure that, you know, the whole game is considered, not just shootouts. So we're just going to use it as a supplementary tool. Southgate might ignore it completely and continue to play, for which there is no mitigations, unfortunately. But then other things such as gambling, expectation reality mismatches. So a few different things there, but I just need to put the last slide on because, you know, it's coming home.
Brilliant. Oh, thank you very much. What wonderful creative sort of, idea you had there. I really like that, and I really like the way you still sort of really thought about some of the potential bias in the data as well. So that was really good. Thank you very much. Fantastic. Okay, so that was Pokey. So Paula, you're up next.
That's me. Just give me a second. Can you see?
Yeah, that's come through.
Excellent. So how to treat ureteric stones. This is a nice example of PowerPoint giving an AI generated slide, but I can tell you that's not a ureteric stone, that is a stone. So there are different ways to treat ureteric stones. So one is something called shockwave lithotripsy that uses sound waves to break up a stone in situ. It costs £500 per treatment. It's a procedure, not an operation. It's very quick. You just come into hospital and leave within a couple of hours. You don't need as many people around, but negative is it might not be as successful as an operation. Whereas an operation uses a laser, which is cool, costs a lot more money, £2,000. It's more resource intensive, but it is considered the gold standard of treatment. So there's a little bit of equipoise between the two treatments, and practice does tend to vary, but using real world example in Plymouth, they tend to give everyone a go with lithotripsy first. And if you fail, you'll then go on to have an operation. Now, if we can create a model which is able to predict individuals who will fail shockwave lithotripsy, they can actually then go straight to an operation instead. That saves cost of the wasted lithotripsy, the appointment so they can go to someone else, the time to the patient and to the organisation. These are the features of which we can collect and would like to collect, as well as the labels for the model. We'd evaluate the model by using confusion matrix. For some reason, it's called that, not sensitivity, specificity, and ROC. And then with regards to the issues, would patients presenting in Plymouth with kidney stones be representative for a North London hospital? No, they probably wouldn't. How could we mitigate against that? Well, we could use some magic machine learning wizardry, such as oversampling of the underrepresented groups. Who owns the data? Is it Plymouth? Do I own it? Is a patient able to ask me to see what the model is? Are they allowed to see the data set? Who owns the data?
Brilliant. No, thank you. A really interesting idea. I like that, and it's I can see that working as a really nice project, and I think you've identified some really nice ideas there for what could go wrong and how you might protect against that. So yeah, really interesting. Nice idea there. Brilliant. Thank you very much. Okay, Motorola, you're up next.
Hiya, that's me, I think. So let me just find the right screen I need to share. Here we go. So something that I am thinking about taking forward as my HSMA project is looking at ventilator waveform analysis. So currently we have a lot of patients on ventilators that are desynchronous in that they are not ventilating in the most efficient way. And we only get involved at the moment when there is deterioration to the patient. So I would like to propose some sort of model in that we could to classify when somebody is not ventilating properly, not only to prevent deterioration, but also to sort of promote a better outcome. So for example, that might mean that their patient spends less time on a ventilator, they spend less time in ITU, they spend less time in hospital, they go home better functioning overall. So in terms of representation, it was brought up that a lot of health data is based on sort of young, healthy men. I've not actually looked at what data might be out there already, but I'd like to collect my own samples from the ventilator waveforms that we generate already. We also identified that sort of pathological lungs would ventilate differently to healthy lungs, and that might then cause a representation issue, and also that we just don't know currently a lot about the causes of desynchrony or how many causes there are. Benefits I've already talked about, but in addition to that, it would also mean that there's development pathways for staff, because this is not something that's taught at a more junior level. So it might help to develop staff to identify issues earlier without the need for an AI system as well. Issues that we thought about were around false positives. So in terms of mitigating that, we said that it would need clinician oversight. And then in terms of false negatives, I'm not quite sure how we would mitigate it, but ideally once staff are able to identify a false negative, they could sort of safeguard over that. And also it's going to be quite time consuming to teach a model different waveforms.
Yeah, no, brilliant. Thank you. Again, really interesting application there. So I can see a quite an interesting project coming out of that. And but yeah, you're right. It's I think a crucial question there about when it gets it wrong and making sure you've got the safety net for dealing with that. I think it's going to be so important. So yeah, really interesting. I'd be curious to see how that develops if you're going to be looking at that as a project. Brilliant, thank you. So a few left. I've got Denise up next.
Well, I think that would be me. 1 second. Hopefully you can see that.
Yeah.
So we were looking at how we might be able to tackle the 8 AM queue for a GP appointment. And that's a big problem that affects kind of most people in our society. And whether we could triage them to a GP, physio, pharmacist, or whether they need to call 999. And the positive things we thought about it was that we could decrease waiting times, we could improve access in terms of having multilingual translation, we could have, you know, a phone conversation. It could be read out for people who can't read, who are poorly sighted. We could integrate the use of images into it. And that if we were able to make it 24/7, we would be able to kind of remove the having to get up at 8 AM when you're sick, but also improve access to shift workers, so people who start work at 6 AM, 7 AM. And then hopefully that by reducing inappropriate demand, that we could better triage people to the correct services. The problems, there were multiple. Removing patient choice. People might want to see a GP, they might want to see a specific professional, or they might not want to write kind of what their problem is into a problem list. People who are triaged as less unwell might be recurrently pushed back, and so we're saying that we need a mechanism to tackle that. We need to make sure that people aren't excluded based on digital access, neurodivergence, diction, or people aren't put off by long questionnaires. And then there are problems with overfitting of pathways. So if a small rash, or is it a big spot? Issues of system gaming or abuse, and then the potential for increased demand if it actually works. So make it harder for GPs. And then the problems of kind of training data. Who does it cover? How on earth would we get access to that kind of thing? How do we diagnose people on a first presentation?
Brilliant, thank you. Again, yeah, really, really interesting, and yeah, throws up a lot of issues. I think that clearly something we can all relate to. I think would be fair to say, and something that would hopefully improve it. But yeah, could I guess cause more issues depending on how it was implemented. So it needs some very careful thought about that. And I really liked the fact that you sort of picked up on you know, people who are neurodivergent, etc. You know, identifying there are groups that this may not work as well for, and so we'd need to be aware of that. So yeah, really nice. I like that. Great, thank you. Okay, so where were we? That was Denise, wasn't it? So Arm, that's right, isn't it? Yes, Arm next.
Yeah, that's me. Let me just share my screen quickly. So what we spoke about is a tool that helps allocate therapist time. So I imagine every stroke unit in the country, their therapist team does not have the ideal resource to meet the guidelines. So this tool is basically designed to, or would ideally be designed to help them make decisions about who they should see and who they shouldn't see. To best allocate that and see patients in the most efficient way to lead to overall the best outcomes for the patients. So this would be trained on data similar to the thrombolysis data set we looked at earlier, with some slight changes to it, obviously. So the pros of this is if you're allocating based on how well a patient could be rehabilitated with your finite resource, overall, you'd have improved patient outcomes, you'd have improved efficiency, you'd be doing everything as optimized as you could be, you'd have better flow, so patients spend less time on your ward and could be moved out quicker. And all decisions would be made with the backing of something data related. So the downside is that this will definitely have patients losing out, even if it works in the most ideal situation. The ethical side is you're still going to have people losing out because people who are deemed to not have rehabilitation potential will be prioritized lower than those who have high rehabilitation potential. It is not a substitute for just having more therapists so you can hit the target. You could oversimplify complex conditions. You have the cherry picking. You could have biases towards younger patients who would recover quicker, and if that's fair or not. And then you've obviously got the data and privacy concerns as well. So in terms of mitigation, we had clinical oversight to make sure you are using the correct indicators. You have the correct data sets. So strokes vary a lot based on obviously the population and all those different variables, and making sure that's correct. And in the end, looking at all of these, we decided it was a better tool to build a service rather than to run one day to day based on all the limitations.
Brilliant. Thank you again. Yeah, no, really well thought out. I like the different aspects you've considered there and how you might combat against them. And you're absolutely right. There is a potential risk there of anything where you are sort of singling out potential patients. There's always a risk because it's kind of like, even if you're seeing it as decision support, essentially you've kind of got a machine whispering in your ear about them, and that can have positive and negative consequences for them, but also, as you point out, for other people who then are being shunted down and deprioritized. And so yeah, really nice. I like the way you thought about that. Brilliant, thank you. Okay, so just two groups left. Apologies, slightly overran, but nearly there. Antic, you're up next.
Yeah, that's me. I'll just share my screen. Yeah, so we don't have any kind of slides as such, but we've got our whiteboard output. So we were talking about the idea of having essentially like an information provision system. So we were talking about this in the context of the charity that I work for, and also in terms of like mental health services. So we kind of were talking about a general idea of having something where you provide signposting of information to people based on their characteristics and their needs. Some benefits being that you can save staff time. So yeah, the charity that I work for, a lot of time is taken on the support line with like providing signposting to online information. And you can also potentially provide information to patients that they don't necessarily even know they need, or information that's out there. So yeah, again, my charity provides a lot of information about like financial support for cancer patients, which a lot of patients don't necessarily realize is even available. So there's potentially some benefits from doing this and providing that information in this sort of automated way. We talked about a lot of different issues, and sort of weaved in some ethical considerations. So you've got similar things that other people have said about having a training data set that is not necessarily representative of everyone who's going to be needing or using the service. Ethical issues associated with kind of assuming people's needs based on their characteristics. So particularly things like financial needs or for needs for translated material. We talked about the correlation and causation issue, and that people will often kind of search information for a topic and that might appear in our training data set, but it's not necessarily the information that they would want to be signposted to in a different context. We talked more generally about the fact that your training data would always kind of exclude people who don't access information in this way. So you've got the technology imbalance and digital divide, and that could potentially kind of increase health inequality gaps as well. Other things like other people mentioned about kind of patients with special needs, and that they not only wouldn't appear in the data set, but this might not be an appropriate way to kind of provide information. And we had an interesting thought about generally this idea of, if we don't have appropriate information in a usable format that patients need to provide off the back of this model, then there's no point in building the model in the first place. If you build a great model but you can't do something useful with it, then that sort of defies the point. So we had that question about, like, is there the resource to use a model that would do this signposting in an appropriate and efficient way? And if not, then you kind of need to go back to square one.
Yeah, brilliant. No, thank you again. Yeah, really well thought out, and a really interesting potential implementation of AI that I hadn't really thought about. So yeah, again, hadn't seen that kind of thing before, but really interesting potential application area there. Fantastic. Thank you very much. So last up, we've got Agnes before Sammy casts her final judgment on who is the most ethical.
Sorry, I put my share screen on and then I lost Teams. Can you see my slide? Okay.
Yeah.
So we were talking about a project that I want to do for my HSMA project, which is looking at how to prioritize patients for pharmacy review. So it's kind of similar to the one about therapy that we had a minute ago. So people quite often miss medications when they're admitted to hospital, and this can lead to harm, because if they miss their epilepsy medication, for example, they can have seizures. And a lot of these errors happen when people are first admitted because their regular medications aren't prescribed, or they're prescribed wrong. So there's a national target that all patients have to have their medicines reconciled by a pharmacist within 24 hours, but there's no workforce to do this. So we have a particular shortage. So we're moving to thinking actually as prioritization rather than aiming to see everyone the best way forward. So the way we sort of think this could work is if we prioritize people based on a model that looks at a combination of their comorbidities, their medication, their illnesses, their demographics, to see if we can prioritize who would benefit the most. We think this would help us target high-risk patients. It would maximize the use of limited resource and hopefully reduce medication errors and improve patient safety. Potential issues, we think there's relatively limited demographic, because it would be based on Plymouth patients, so they might be older, not very ethnically diverse. So if they tried to roll this out nationally, it may not learn well for other places. It wouldn't consider social circumstances, but these can have a significant effect on medication use. We need to understand how patients are being scored, and we were having a discussion about whether you need to tell patients, and if you do, how you explain it to them that they might not be seen, and some might never be seen. And then how do you define or measure the benefit? Because managers will look at it one way, staff patients will look at it another way, patients will probably define it differently still. And then potential negative consequences, as selectively seeing people goes against national targets, but we could use it as a clinical improvement tool. It might be seen as a way to reduce staff rather than address workforce issues, because you can do it, or the model might go against other pharmacists who think prioritization should be done differently. So you might get some conflict between clinical expertise and the model.
Yeah, no, great, thank you. Again, really interesting and creative use of AI there in an area, again, I hadn't really considered. That one, I think, particularly if you're thinking about that for an HSMA project, that feels ripe for some patient involvement. And so it would be probably worth looking at the links we put into the session, was it session 1D? No, 1B, I think it's the, yeah, it was 1B. So dig out the slides for 1B, and there's some links to some of our patient involvement group resources. It would be worth, I think, looking at that, because that feels like you kind of want a variety of stakeholders, because everybody, as you say, is going to have a different idea about what the priority should be, and it's all about, essentially saying some people aren't going to be seen because of this. So yeah, I think that's a potentially really interesting, but a lot of you'd want a lot of input in that, I think. So yeah, brilliant. Thank you. Well, what fantastic ideas, and really great to see you've all really thought about some of the ethical considerations as well. So hopefully what we've been talking about this afternoon has helped you to think about that. So I'm going to pass over to Sammy now, who has the job of deciding which of you are the most ethically aware and which ones came up with, in Sammy's opinion, the best presentations this afternoon.
Thanks, Dan. Difficult as always. There's some really good stuff being discussed. So I will give my snap judgments, which I'm going to award joint bronze to Paula and Sid. I want to award silver to TIA, and gold is going to ARM, particularly there for that kind of real nice recognition of how the model may be kind of better used outside of day-to-day service, and how that could avoid still provide a lot of benefit while avoiding some of the ethical implications. But I will be putting together some ad hoc points as well for other great discussion points that I couldn't recognise. Otherwise, you were all ending up with points today. So, so there will be some ad hoc points coming out after this.
Fantastic, thank you very much, Sammy. That's great news. Well done to it was ARM. Sorry, who was gold? Sorry.
Yep, yeah, ARM with gold.
But I couldn't even remember 5 seconds ago. Wow. Yes, well done, ARM, and to all of the groups at the top tier, and to all of you who've done some fantastic work today. And as Sammy said, there'll be some more ad hoc points beyond that for some great discussions and ways of working we've seen today as well. So do look out for that. So fantastic. Thank you very much. Thank you for staying with us a little bit after the cut-off, for those who could. I hope you've enjoyed today. I hope this has been a good introduction to some of the practical ways you can do machine learning, and also some of the practical considerations for thinking about whether you should be doing machine learning and how you might approach problems. Just a reminder that tomorrow we've got our second project development clinic. Again, optional drop-in clinic. Sammy and I will just sit there for an hour and see if anybody turns up, which it turned out last time loads of people turned up. So we will do our best to get through you if you've got lots of questions. But as a reminder, you can also use the channels on Slack as well, which is the project ideas forum. If you just want to put out an idea and you want a bit of feedback on it, and then kind of when you're ready to register your project, you've got a fully formed project idea, that'll go in the airlock. But for most of you, that won't be until towards the end of phase 1, so you don't need to worry about that channel at the moment too much. But yeah, please come along tomorrow if you've got anything you'd like to talk to us about. We're more than happy to give our advice, as you know, not that we are necessarily have the right answers, but hopefully we can try and give our gut instinct and nudge you in the right direction for things that might help. So next week it's Sammy. So Sammy will be taking over and talking to you, I hope I got this right, about random forests in the morning, and explain what afternoon. Is that right?
Almost. We're covering decision trees and random forests in the morning. In the afternoon, we'll be doing boosted trees and regression trees as well.
I knew it was something machine learning. There's a lot of things to remember. Okay, I was close. But yeah, so again, some more approaches that you can use before we get on to, in a couple of weeks' time, where we're taking you through some of the deep learning stuff, neural networks, and we look at some of those approaches too. So until then, have a good week, everyone. Any questions or any ideas that you have, as I say, please share them on Slack. Otherwise, we look forward to seeing you next week. Bye, everyone.